Let's take a look at some math problems that involve vectors. So first of all, let's talk about what a vector is. I really like this comic here. It says, bag of gold, 20 meters, which way? And I think this does a good job explaining a vector because sometimes we need to know more than just a quantity. We need to know a direction. So a vector is both a quantity or a value, a number, we call it a magnitude, and a direction. We typically notate them as rays, and they can be any direction, any length, typically drawn to scale. And the direction can be measured as an angle from the x-axis. So this would be the direction. And the magnitude is the scale of the vector here. So let's see, magnitude is the length there. So that's what a vector is. We can have two vectors and we can actually add them together. In a vector, this end is called the tail and the arrow end is called the head. So if we wanted to add two vectors together, the tail of the next vector would come up against the head of the previous vector, just like so. And then the resulting vector, or the answer to our addition problem of vectors, would go from the tail to the head, or to where the other head ended, with a new vector in this direction. So the sum of this vector and this vector equals this third vector in the dotted line. So we can look at that graphically, but I want to show you how to do it algebraically. It ties in really well with triangle problems. So let's take a look at some examples. First problem, Oren Boatwright is rowing at a 60-degree angle from the upstream direction as shown. Find his angle, velocity, and direction. So it's really hard to see this, but we have an angle here, 60 degrees, and the boat is rowing at 2 miles per hour, but the current of the stream is pulling down at 1.5 miles per hour. So basically, the boat is not really traveling in the direction of 6 degrees because it's being pulled back by the current. So we want to see the actual velocity and the actual direction of the boat. So I'm going to add these two vectors. And if I were to just add them kind of graphically on this picture, I could add the second one down here. And my result is going to be something like this. But let's see what happens when we do it algebraically. So the first thing I want to do is I want to split apart the two vectors, and I want to find the x and y components of them. So I'm going to draw the first vector. I know that it has a 60-degree angle here and a magnitude of 2 miles per hour. So I'm going to write that 2 miles per hour here. And I'm going to create a right triangle with this vector. So the easiest way to do that is just to connect over here. This is a right angle. And when I talk about finding the x and y components, I want to find this y distance here and this x distance here. Then I have my second vector, and it's just going down. So this is actually pretty easy. This is 1.5 miles per hour. And this is just a y component, so I don't really have to split up anything with this one. So step 2 is to find the x and y components for each vector. I'm going to use my trig relationships to find what x equals and what y equals for triangle A. I'm going to call this A, I'll call this B. So for A, x is going to be, let's see, we can take the sine of 60 is x over 2. So sine of 60 equals x over 2. And to find the y, I can take The cosine of 60 is y over 2. Cosine of 60 equals y divided by 2. Now I need to solve this and find my values. Okay, so I have sine 60. Remember, make sure you're in degree mode on your calculator. Times by 2. So x is approximately 1.73. And then I can do my cosine of 60 multiplied by 2. And y is 1. Okay, and then on b, well, x is going to be 0, and y is just 1.5. Because I don't even have a triangle. Okay, so I've now broken down the one vector to the x and the y component. And now I'm going to add all my x's up. So the x from the first vector plus the x of the second vector. So my x's are going to just be 1.73. And my y's, the y of the first vector is 1. The y of the second vector is 1.5. So I have 2.5 is the sum of my y component. Okay, next step, we're going to take the x and y component. We're going to create the new vector. Oh, but I just saw a little mistake. This vector is actually pointing towards the negative direction. So we need to make sure it's a negative 1.5 miles per hour, which means this will be negative, which means we are adding a negative here, which actually means that we have negative 0.5. Good thing we caught that mistake. It's so easy to make a mistake. Okay, so now we're going to take these two new pieces and we're going to draw the resulting vector. It's actually going to be a triangle. So x is going over 1.73 miles per hour. The y component is down negative 0.5 miles per hour. And so our resulting vector is going to come from this point down here. And you can kind of see that that's about the right direction as where I was in the picture up here. Okay, so now I need to know what is this resulting vector. We could call that x. We'll call that r, so we don't get confused with the x component. And then I need to find the angle because that's going to be my direction. So to find r, I can use Pythagorean theorem. A squared plus b squared equals c squared. Okay, 1.73 squared plus negative 0.5, 0.5 squared. And then I have to take the square root of that. So r equals 1.8, and this is going to be miles per hour. And now we need to know the direction the boat's heading. So we're finding theta here. So we can do actually the tangent of theta is opposite over adjacent. So then we do inverse tangent. And we find that, let's find our answer here. Negative 0.5 divided by 1.73. We get an angle of negative 16.5 16.1 degrees. So our vector is 1.8 miles at negative 16.1 degrees. And I'm just going to notate that this is from the positive side of the x-axis. Because there's different ways that vectors are measured, and we're going to look at that in other problems. Okay? So we need both that magnitude r, the result, and the direction. Those are the two pieces that you actually need to find the answer to.